All right, everyone. My name is Samer El-Haj Mahmoud. I'm a Senior Principal Architect at Arm, and I'm joined here with my colleague.
Hi, I'm Peter Pouliot from Ampere Computing.
And today we are going to talk about Arm and Ampere and support for standards-based open system firmware. So first, we will talk about the Arm SystemReady program and how standards-based approach for server development is used in this program. So Arm SystemReady is a certification compliance program from Arm with the vision that software can just work on Arm-based devices, ranging from servers all the way to the infrastructure, edge, and IoT devices. So the program is based on industry standards and standards from Arm, so requirements, specifications for the firmware, for the hardware, allowing device manufacturers to focus on providing value in the upper layers and allowing software like operating systems and hypervisors to work across these devices, migrating workloads from data centers all the way to small devices, being able to run them using software that is not customized for every device. The program is divided into bands, allowing for some tailoring of the program for the different market segments. There are 4 bands: the SystemReady SR, ES, IR, and LS. In our talk today, we are going to focus on just 2 of the bands that are related to servers and to what we are presenting today: the SystemReady SR and the SystemReady LS. The SR is tailored for servers, workstations. It is based on standards that allow pretty much any operating system that supports Arm64 to run on these devices. So if the device is, or the server is SystemReady SR compliant, that means it can run Linux distros, the various distros without customization, BSD distros, Windows for Arm, VMware for Arm, older operating systems running on newer hardware or newer operating systems running on older hardware. It's that interoperability that you get from these standards. SystemReady LS is based on LinuxBoot open system firmware approach for servers, for Arm servers. So it is tailored more for the hyperscalers and customers that want to run LinuxBoot and open system firmware, ensuring interoperability with operating systems that run on top of LinuxBoot. So the foundation of this program is a set of standards that Arm developed that are based on industry standards plus Arm added requirements. The standards range from silicon requirements with the Arm BSA, the base system architecture specification, and extensions to the BSA that are market segment specific. For example, the SBSA, which is the server-based system architecture, it is additional silicon requirements specific for the server market. So it starts, compliance with the program starts with the silicon and pre-silicon before taping out and meeting the requirements in these specifications and building silicon that's compliant. And then we have the BBR, or the base boot requirement specification. The base boot requirement specification defines a number of tailored recipes that leverage common industry standard interfaces and components for the operating system, like UEFI, like ACPI, like SMBIOS, like device tree, and allow for some variations using these recipes for different segments in the market. The 2 recipes, the 2 program bands I mentioned earlier, the SystemReady SR and LS specifically, would fall under the SBBR and the LBBR recipes that are defined in the base boot requirement document. In addition to these foundational requirements that we have for silicon and for firmware, we also have standards-based requirements for the system management subsystem for the control plane. So with the Arm SBMR, with the server-based manageability requirements specification, similar approach is based on industry standards, so it leverages DMTF, Redfish, MCTP, PLDM, and other standards, IPMI and the OCP hardware management requirements, and in order to provide consistent management functionality and approach to designing the manageability system of servers, of the Arm servers. So putting it together, these requirements on the system-ready side, the silicon and the firmware, along with the requirements on the manageability side, they're based on industry standards that span the industry, added Arm requirements and Arm specifications, and can be implemented across the board using either open source firmware like OpenBMC, Tiano Core, LinuxBoot, or commercial firmware. So we do not require one or the other. We work on enabling both in the ecosystem. And by following this approach, the standards-based approach for design and implementing the firmware, open source or commercial, you enable this rich ecosystem of software to just work on Arm devices. And Peter?
So we at Ampere are very committed to ensuring our platforms, adhere to industry standards, right? And as such, we help to participate both in the fleshing out of requirements as well as ensuring that our first platform, the Mount Jade, achieved system-ready status. And we look forward to helping to ensure that we can build and work with industry standards on our platform going forward. So this is the Ampere Mount Jade platform, as we said, the first system-ready certified platform in the industry. It's houses our flagship product, the Ampere Ultra 80-core chip in it, and comes in a 2P form factor, and it is our first OCP accepted platform here at Open Compute, which happened this week. So Ampere also, in the spring, we announced our commitment to working with open source firmware and support for open source firmware on our platforms. And as such, we are working to enable the different components of the open firmware stack on our platforms for our customers. And we are actively engaged in the continuing upstream contribution to support our platforms in the community. And the projects today that we currently support are Tiano Core EDK2 and LinuxBoot, OpenBMC, OpenOCD for debugging, and then we have additional OCP and OSF efforts to help to enable our platforms both in this community and other communities. And the whole idea about the Open System Firmware project, from our perspective, is to allow platform owners to own their firmware and to have a stake in the actual platform itself. One of the central compliance requirements is that the firmware be open source and have freely redistributable binaries. And Ampere is going to continue to work towards certifying not just our Mount Jade platforms and ensure that they're OCP and OSF compliant in the previous months and coming months, ensuring that we continue our path of certification. And additionally, much of the stack that exists today for the open source firmware is available to see at the show in our booth if you want to take a look. But yeah, at the end of the process, the firmware components of Mount Jade will be available on the OCP website, which we help to enable through our submission process.
All right, so part of our enablement for the ecosystem to be able to build open source firmware that's compliant with our standards is paying attention to these open source projects, contributing to them, building an ecosystem around them. It's not just ARM, it's our partners and our suppliers that build these systems. And Tiano Core is an example of these projects. It's important specifically for the SystemReady SR band because it's an open source firmware that implements the ARM SBBR requirements of UEFI, SMBIOS, ACPI, and the additional ARM-based boot security requirements that include requirements around TPM and secure boot. So ARM participates in the project, Upstream, our reference platforms, enablement for our new cores, and we have some maintainership role in some of the projects associated with Tiano Core, like the UEFI self-certification test, one of the testing components that is used in the Arm SystemReady certification program. You will find a number of ARM platforms across the board, ranging from IoT to servers that are fully contributed, open source, and maintained upstream in the EDK2 platforms project.
From an Ampere perspective, we enabled support for Ampere Ultra on Mount Jade with Tiano Core. And we're continued, as I said, to continue to contribute upstream with the efforts that we're making around that. The latest releases that we have can be found on our GitHub page. And we began support for Tiano Core and UltraMax in March of 2021 this year.
Right, but we also want to enable the additional recipes in the ARM SystemReady program and our base boot requirements. So in addition to Tiano Core and SBBR, we're also working on enabling the Linux base boot requirements or LinuxBoot base requirements or the LBBR recipe. So we are working with the ARM partners with the ecosystem in defining those requirements. Will be published soon in an updated revision of the base boot requirement specification. That is going to be the foundation for certifying SystemReady LS compliant servers. So that are servers that meet the hardware silicon requirements and are loaded with firmware that meet the LBBR requirements for LinuxBoot. We have multiple demos and proof of concepts that we are showing in the OSF Experience Center, ranging from Ampere showing the Mount Jade platform running LinuxBoot. We are showing Raspberry Pi, as well as virtual platforms, the QEMU and the ARM FVP, which is our virtual platform reference code for the Neoverse server-grade cores that are released by ARM. We have the knowledge, the how-to, the recipes of how to build these platforms and how to port it to other platforms, all published on our GitLab. And we plan continuing the education and the support in enabling the community to build more LinuxBoot compliant systems. Here you go.
Thanks. And as I said before, Ampere is also committed to contributing to LinuxBoot. We've done the work to help enable it for the Mount Jade platform. And you can go and find it along with our EDK2 work on Ampere's GitHub page. And we're going to, as I said, continue to be integrating these technologies into our future platforms as well.
All right. And in addition to system firmware, we, with our SBMR requirements, our base manageability requirements, we work with partners in commercial firmware as well as open source firmware. The OpenBMC is the project we're focusing on for SBMR. ARM sits on the OpenBMC Technical Steering Committee. We're helping in developing and upstreaming features to OpenBMC that are specific for SBMR, including the sideband management of ARM servers, leveraging MCTP and PLDM technologies that includes things like streaming telemetry and events and RAS error reporting from the ARM SoC to the BMC.
As we said before, Ampere supports OpenBMC on our platforms. As Samir said, you can come and see it at our booth, earlier this week. Yeah, we're continuing our upstreaming processes. The base meta Ampere and SSIF bridge has already been upstreamed. There's additional code under the meta Ampere continues to be upstreamed over time. And the SM Pro MFD drivers will be upstream, are currently pending for upstream review. So these are the links to all the Ampere-enabled technologies that we're talking about today. As I said, you can find them at these links underneath our GitHub repository or other project repositories.
And finally, call to action. If you are in the ARM ecosystem, please contact us to get involved in SystemReady and this journey to standard and open system firmware. And you can check the SystemReady certification program and contact us at this link on our webpage. And visit the Ampere and the ARM booths if you still have time in the OSF Experience Center or in the Expo hall. Thank you, everyone. I have time for questions.
So I know the core boot community, there's a lot of interest in doing a port, but they can't afford a board. Does Ampere have a simulator that they could use as a starting point for such a port?
We don't have that to provide, but if you reach out to me, I can see, let's chat after this, and let me see what I can do to help enable that community.
Thanks, Juan.
Any other questions? All right.
All right, thanks, everyone.